implicit differentiation problem. I'm going to go through it. So basically, we just need to be careful with how we apply the rules for differentiation here. We need to notice that there's a product rule and a quotient rule in this problem. So let's go ahead and get started. So here's my curve, and they want dy dx. Again, they want us to just differentiate this implicitly. So we need to notice that this is a product. This is x times y. So 1 is going to take the role of the 1 function, right? And we just need to remember product rule, and I'll put it just right here, f prime times g plus g prime times f. And just take your time. Look, x takes the role of f, and then y squared takes the role of g. So I have here that x, the derivative of x is just 1, times g is y squared, plus the derivative of y squared is 2y dy dx. And then times f, which is just x, plus, and now here you need to use the quotient rule. So I differentiated this first term. I'm done with this. The derivative of x is 1 times y squared. The derivative plus the derivative of y squared is 2y dy dx times x, the other f. Now here, the quotient rule is f prime times g minus g prime times f over g squared, where now x squared takes the role of f and y takes the role of g on the bottom. So now let's use this fact. So the derivative of x squared is just 2x times g minus, you have here, so I'm going to put this in parentheses, minus g prime is dy dx, the derivative of y, times f is x squared, over g squared, which is y squared, equals, and I'm going to try and get this out of my way now, equals, the derivative of 5 is 0. And now in here, we just need to be careful. We just need to make sure that we can solve for dy dx. Okay, that's just an algebra problem now. Okay, so let's do that slowly. Y squared plus 2y x. I'm gonna put the x over here. 2yx dy dx plus, and I'm gonna put the y squared and cancel. I'm gonna write it as 2x over y minus dy dx x squared over y squared equals 0. And okay, now I want it with all the terms with the dy dx, I want them on one side. So this term and then this term I'm going to keep on the left hand side, and I'm going to wind up with 2yx dy dx minus x squared y squared times dy dx is equal to, and now when I move everything else over, so this has got to move over and this has got to move over, negative 2xy minus y squared. And then now I can factor out a dy dx from this. I'm left with, on the inside, 2yx minus x squared over y squared is equal to negative 2xy minus y squared. And now I have this here. I could divide by that entire thing, and I'm going to get an expression for dy dx. So dy dx is going to be equal to negative 2xy minus y squared, all of it divided by this 2yx minus x squared y squared over y squared. Now, if you look here, none of them look like that, which is fantastic. But what I'm going to do is I'm going to try and modify this to see which one it's going to be. So basically, y I'm going to get a common denominator here, and I'm going to get a common denominator on the bottom. Again, more just algebra, which is a real pain, but we got to get through it. So let's see. Negative, I'm just going to work with it over here in green. Negative 2xy minus, if we look, y squared is the same thing as y cubed over y. And then this is the same thing. The entire top part is just negative 2x minus y cubed all over y. That's the common denominator. And then the bottom, I'm going to get a common denominator as well, and I'll do that on the right over here. So I could just kind of like flip over here and see which one it's going to be equal to. So it's going to be 2y cubed x minus x squared all over y squared. And you should see that this is equivalent to this bottom part. Why? I got a common denominator. So this was over 1. So I multiplied by y squared on the top and bottom of this term. And I get this here. Now I'm dividing by that entire term, right? So it's going to be this divided by, it's going to be this. No, it's going to be this. Yeah, it's going to be this divided by this one. So it's this one divided by this one. And when I divide by this one, I flip and multiply. So it's y squared over 2y cubed x minus x squared. And one of this y cancels with one here, so I have a y on the top. And then I'm left with negative 2x minus y cubed times y over 2y cubed x minus x squared. And that becomes, if you look, it's sort of tricky, but this here is going to be the same as b. Okay, at this point I can tell with confidence that these two are the same, this one and this one. Why? Because if I factor out a negative 1 here, right, this becomes positive, and it's negative 1y, right? That's the negative 1y. And then on the inside, I'm left with the 2x plus y cubed. Here, if I factor out an x, I'm left with 2y cubed minus x. And that's what I have on the inside here, and then the x is on the outside. And the bottom is the same.